Dear students, once again, welcome back to Grade 9 Mathematics e-learning program. Before we start our period 1 or the first period, I would like to remind you whenever you use this platform or any platform for learning maths, be ready with a copybook and a pen with you because as you know, learning mathematics without practice will not be perfect. So we want you to benefit maximum out of this program. So please be ready with a copybook and a pen. Not even a paper, copybook will be better so you can use it for your future reference. Okay, let's start now. First, we will go to the chapter number 1, which is about number systems. At the very outset, let me read for you the main objectives of this chapter. Define rational and irrational numbers, decimal representation of rational and irrational numbers, operations with square roots, rationalize denominators with square roots, properties of exponents. These are the main objectives. And now we will get into each one of them one by one. So at first, I would like to remind you about the set of numbers that you learn in smaller classes, which started from natural numbers, which is represented by the letter N, which is the first letter of natural numbers. But remember capital letters. These are also called as counting numbers. This is another name, counting numbers or natural numbers, because these natural numbers are usually used for counting. Imagine a situation when you want to count the number of students in a class. We start counting from 1, 2, 3, 4 and continue. So natural numbers, the least natural number is 1 and it goes on and on. In the Indian system, we continue lakhs, crores and continue to infinity. And in international system, we continue from 1 to million and million, billion, trillion and also again to infinity. Hope you know what's the meaning of infinity. Means countless, which continues on and on. Next set of numbers is whole numbers, which is represented by W, which is the first letter of whole. Again, capital letter. The only difference between natural number and whole number is that you have an additional 0 here. Natural number starts from 1, whole number starts from 0. That's the only difference. Because we need to represent a situation when there is nothing. For example, in a class, the whole class went for the break. So we have 0 students in the class. Next set of numbers include negative numbers as well. They are called integers. Integers, remember, it is represented by the letter Z and not I. This is from Greek language. Here, the difference is that the lowest number is not 0. We have to consider the infinity from both the ends. We have negative infinity, and closer to 0 we have -3, -2, -1, 0, 1, 2, and again until positive infinity. So integers has negative and positive numbers in addition to 0. Now comes the real objective of this chapter, which is rational numbers. Again, note that rational numbers are not represented by the letter R, it is represented by the letter Q. Why Q? I'm coming to that in a minute, but let me say what is a rational number. Rational numbers are numbers which can be in the form of fractions or it can also be represented in the form of decimals. Okay, as fractions, it is represented as 3 by 5 is an example, or half is another example, 1 over 2, 3 over 4. These are all rational numbers. Even mixed numbers can be considered as a rational number. 3, 2 by 5 or 2.5. These are all rational numbers. And not only positive numbers, you can also have negative or fractions as rational numbers. In short, rational numbers are those numbers which can be represented in the form of P by Q, means a numerator and a denominator. But there is a condition that the denominator can never be equal to 0. Why it can't be equal to 0? We will come to it also in the next slide. Okay. So rational numbers are represented by the letter Q, and few examples are 3 over 5 or negative 1 over 2, 3 over 5. These are all some examples. And the denominator cannot be 0. Now, why do we use the letter Q instead of R for rational numbers? Rational numbers derived from the word ratio. You know, ratio means just comparing two quantities. It's a ratio. And the final answer of ratio you can either simplify, or when you divide you will get a quotient. That quotient is really known as rational number, and from the word quotient we have the letter capital Q, which represents rational number. Okay, now we just talk about why we can't have the denominator 0. Consider a situation when you have a bar which is, there are 3 parts for a bar, 3 blue parts, and you are asked to color 2 parts orange. So here it's written for, it's marked for you. So what part of this bar is orange? So it is 2 by 3. There were 3 blue and 2 are oranges. Now consider a situation when it's written 2 by 0. Does it make sense? No, right? Yes, exactly, because it means that when you have 0 bars, how are you going to shade 2 from that? It is meaningless. So whenever you have a fraction with a 0 denominator, not numerator, when you have a 0 denominator, it is undefined. That is why you can come across the condition Q not equal to 0, which means denominator cannot be 0. Hope that is clear to you. Okay, now let's move on to some of the examples related to this lesson. Here we go. Finding rational numbers between two numbers. Now we need to find a few rational numbers between 4 and 5. You know, 4 and 5, what type of numbers are they? Can you guess? Is it whole number, natural number, integer, rational number? Yes, exactly. These 4 and 5 are all of them. 4 and 5 can be a natural number. It is a whole number. They are integers. They are also rational number. Do you wonder why they are rational number? Here is the answer. Because we can rewrite 4 as 4 by 1 and 5 as 5 by 1. So we have P by Q. Q is not equal to 0. Now again, you can see that the denominators are 0, but between 4 and 5 there are no numbers. So what we do? We find equivalent fractions for 4 by 1 and 5 by 1. So you can multiply by any number you wish, but it should be the same in the numerator and the denominator. Let me multiply by 10 to make it easy. Multiply by 10 up and down, you will get 40 by 10 and 50 by 10. Now you are free to find 9 numbers in between 40 and 50. And here are the answers. So we can say 41 by 10, 42 by 10, and you can find 9 such numbers in between 40 by 10 and 50 by 10. But what if you want to find around, let's say, 25 numbers in between 4 and 5, or 63 numbers in between 4 and 5? Don't worry, here is a solution as well. Instead of multiplying by 10 in the numerator and denominator, you can multiply by 100 in the numerator and denominator. If you want to think about 1000, you can also go ahead, multiply by 1000 in the numerator and denominator. So here we get 400 divided by 100 and 500 divided by 100. Now you are free to choose any 99 numbers in between these two fractions. So that will be the answer for rational numbers between 4 and 5. Let's choose another example. Finding few rational numbers between 2 by 3 and 3 by 4. But here, did you notice that the denominators are not the same? But don't worry, you know how to make them same. you can choose the LCM. Between 3 and 4 is 12. So make the denominators 12. Multiply by 4 up and down with the first fraction, and multiply by 3 up and down with the second fraction. So the first fraction is 2 times 4 is 8, and 3 times 4 is 12. 3 times 3 is 9, and 4 times 3 is 12. So we have the numbers 8 by 12 and 9 by 12. Now, can you guess the way how to find some numbers between few numbers between 8 and 9? Right now we don't have, but we studied in the previous question. We can rewrite 8 by 12 as 80 over 120 and 9 by 12 as 90 by 120. Now, isn't it easy for you to find 9 numbers in between them? 9 rational numbers between 80 by 120 and 90 by 120. Okay, you can write it down them here. 81 by 120, 82 by 120, 85 by 120, and so on. But remember, if you write 82 by 120 or 85 by 120, you need to simplify. We will come to it in the next example. So here we will move with exercise 1.1. The first question is 0 a rational number? Think for a moment, and what do you think? Is 0 a rational number? If you are confused, recall what is the definition of rational number, which means a numerator and a denominator, but you can't have a 0 down, 0 as a denominator. So here is the answer. Yes, 0 is a rational number because we can write 0 as 0 by 1. Numerator is 0 and denominator is 1, which is not equal to 0. So this is a rational number. Next question is to find 6 rational numbers between 3 and 4. Just a similar question, just now we did it. So you will be an expert to do this one, right? So pause here, try it yourself to make yourself comfortable. Feel comfortable. Hope you get the answer and you can check it now. You can rewrite 3 and 4 as 3 by 1 and 4 by 1, which is 30 by 10, 40 by 10, and you can choose numbers in between them. But this is what I talked to you about. 31 by 10, you can choose 32 by 10, but 32 and 10 is not simplified. So try to choose odd numbers. Again, don't choose 35 because you have to simplify. But when you choose odd numbers other than 5, you have only 4 numbers here. So let's choose 32 by 10. Simplify, divide by 2 in the numerator and denominator. So you will get 32 divided by 2 is, great, 16, and 10 by 2 is 5. And choose any other number, let's say 35 by 10 or 36 by 10, anything. 36 divided by 2 is 18. 10 divided by 2 is 5. A similar question, but another one now. Find rational numbers between 3 by 5 and 4 by 5. Pretty easy, right? Because especially the denominators are the same. So you don't have to worry about the LCM or cross multiplication. But the only thing is you have to multiply by 10 to make them same up and down. So between 30 by 50, 40 by 50, you have 9 numbers. You can choose them provided you simplify if it is not. Okay, now question number 4 is to say true or false. The first question is every natural number is a whole number. All naturals are whole. Yes, it's true because natural numbers and whole numbers are exactly the same. The only difference is the whole number has an extra number 0. So all of the numbers in natural number is there in the whole number. And I will also tell you a trick. In the order that I explained to you in the second slide, all of the above ones are in the below ones, but the opposite is not true, which means all n is in W, all W is in Z. So all the ones at the top are there in the ones in the lower parts. That's a clue for you. Now the next question is every integer is a whole number. See, now you can apply the trick. Integer is the set which comes below, and whole number is the set which comes above. So in integers, for example, you can see -3 is an integer, but negative is not a whole number. So not all of the integers are whole numbers. And now coming to the last question here, which is every rational number is a whole number. Every rational, again apply the rule that I told you. Rational is the last row, you can't go up. So you can say that. Guess what can you say? If you take a rational number 3 by 5. 3 by 5 is rational because it has a numerator and denominator, but 3 by 5 is not a whole number. Is that clear now? So we are done with the first part of your first chapter. You have done a wonderful job if you were following up with me. That's all for today. Thank you for watching the video. Don't forget the instruction that I gave you in the beginning of this period to continuously work on the exercise and the questions that we give, and also try some questions alone or online platform. You can choose more questions and keep practicing to be perfect. And that's all for today. Have a good day. See you soon in the next period. Bye for now.